Okay, so in chapter 1.1, we will look at the elimination, okay, as well as the substitution methods to solve a pair of simultaneous equations. Okay, so what are these two methods all about? In the elimination method, we will try to eliminate or get rid of, okay, one of the variables, one of the unknowns, either x or y. Okay, whereas in the substitution method, we will try to make one variable, okay, the subject of the formula, and we will perform a substitution. Okay, so to understand this better, we will look at some concrete examples. So in example number 1, by elimination, okay, we will first want to get rid of, okay, or eliminate one of the unknown. Okay, so what I'm going to do, I'm going to call this equation number 1 and call this equation number 2. Okay, so think of it carefully. Okay, if let's say I want to get rid of the x component, okay, I will take equation number 1 minus 2 copies, okay, 2 times equation number 2. Okay, so how exactly do I do this? So I will use the left hand side of equation number 1, which is 2x plus y, minus 2 times, okay, the left hand side of equation number 2, so x plus 2y. Okay, why am I doing this? You'll see some magic happening in a while. Okay, so similarly, I will take the left hand side of equation number 1 minus I'll take the right hand side of equation number 1 minus 2 times the right hand side of equation number 2. So 2 times 7. Okay, if I were to expand this out, I'll get 2x plus y minus, okay, 2 times x will give me 2x, negative 2 times positive 2y will give me negative 2y. Okay, which is, negative 4y. Okay, and 5 times 5 minus 14. Okay, and if I were to look at this carefully now, 2x minus 2x gives me 0. So the x component is gone. Okay, whereas y minus 4y gives me negative 3y. Okay, and 5 minus 14 is just negative 9. So finally, to get y, I just divide by 3 throughout. So I get y is positive 3. Okay, take note that at this point in time, I'm not done. So I need to sub y equals to 3, okay, into equation number 2. Okay, so x plus 2 times 3 gives me 7. And so x is just 7 minus 2 times 3, which is 6. And so x is just 1. Okay, so I've just solved the pair of simultaneous equation using the elimination method. Okay, so I'm going to switch to a different color now, and I'll show you how we can do this using the substitution method. Okay, so by the substitution method, what we will do is we will first make either one of these unknowns the subject of the formula. Okay, so from equation number 2, I will try to make x the subject of the formula. So how do I do that? I will just shift the 2y, okay, the 2y over to the right hand side of the equation. So 7 minus 2y. Okay, next I'm going to sub x equals to 7 minus 2y into equation number 1. Okay, and what's happening over here? 2 times x. So x is 7 minus 2y plus y is equals to 5. Okay, so if you just take a look at this very carefully, this equation very carefully, you realize that there is no more x component. Okay, we're just left with the y's. Okay, so it's easy to solve now. So 4 times 7 gives me this. Okay, sorry, 2 times 7 gives me this. And if I just expand this out over here, okay, I'm going to shift the 14 over to the right hand side of the equation. Okay, concurrently, negative 4y plus y gives me negative 3y. Okay, 5 minus 14 is just negative 9. Okay, so similarly, by dividing by negative 3 both sides, y will be 3. And recall that earlier we found that x is 7 minus 2y, so x equals to 7 minus 2 times 3. Okay, since y is 3. Okay, and if I were to solve this, x is just 1. So similarly, I arrive at the conclusion that x is equals to 1. So the conclusion is x equals to 1, and then y is equals to 3. Okay, so I hope you appreciate both the methods, and take some time to think about both the methods, because in certain scenarios the elimination method will be easier, and in certain scenarios the substitution method will be easier. Okay, so I'll see you in the next example.